6.4 Review and feedback. Giving feedback to my performer may be quite difficult to do, as they may take negative feedback badly. So I'll have to be considerate of how the person will take the criticisms, um, as it's very important because it may damage their confidence. So this can be done a few ways. So firstly, considering the performer's current confidence levels. For example, if they're low at the time, they will be very sensitive to criticism, um, and could get upset or maybe not believe you, or yeah, so maybe think they're doing it okay, whereas they're not. So that could be a very difficult situation to manage. Also, I would consider the language that I used. So, for example, not using technical language as much to maybe confuse them when giving feedback, because they might get a bit confused when you're explaining something to them. So, using simple language will make it more understandable and more easy to take in. And then in the image, the structure of feedback is quite important. So, this is known as a feedback sandwich, where you could try and conceal negative feedback with two little positive pieces of information to maybe not make them feel as bad as with the negative feedback. So, for example, saying, "Oh, well done, you did this right, but you didn't quite get this right," and then another bit. So, and then you corrected yourself. So, just maybe thinking about how to structure it will make the performer like happier with it, to an extent. And then finally, you could also consider the personality of the performer. Maybe if they're quite a quiet, to themselves person, they may not take criticisms too well. But also, if they're quite loud and like confident, they may also not believe your negative feedback as they think they're probably doing it right, whereas they're probably not. Um, so I'll go to the factors influencing performance. Um, so the performer may not perform as well, for a few reasons. So firstly, they may have low motivation at the time. For example, in tennis, they may not be as motivated to do their serve as hard, or as well. So they're being quite inconsistent there. Then obviously their ability level. So they may not be good as someone else. So comparing them to someone else wouldn't be a very good idea when thinking about their performance. Then also their age, they may not be as good because they're younger. Um, or if you've got an older performer, so yeah, may not be may should be better maybe or something like that. And then group dynamics. So for example, if it's a group, um, and some people may want to impress someone in the group or something like that. Um, just yeah, how the group works as a whole. And then this is sort of on the same level, the pressure from spectators or potentially a camera. For example, if you're doing something in front of a group, um, you might feel under pressure and not perform as well as you're nervous. Um, yeah, and also the camera may increase the nerves that they have. Um, so talking about my player, he is a small forward, which is also known as the number three position in basketball. Um, Assets that they need: versatility, so they're able to play different positions and move around the court. Fast, as is important because their aim is to break down defenses, maybe go through them. Um, Accurate with their passing, and again agile to help them get through the defenders. So going through the um, my assignments. So in 6.1, we watched a live game of basketball, and analyze an individual. So on the left is the schematic, which is sort of a heat map um, of their movement around the court. As you can see, it's quite inconsistent. So that sort of tried to stay to the left slightly, um, but yeah, they are sort of all over the place. Um, and then on the right is an Excel spreadsheet which we use to see a comparison between statistics. So basically, during the game, we constructed a tally chart of different stats, so passes, layups, rebounds, stuff like that. On the right is the correlation and relationship between the amount of offensive and defensive rebounds of every player in the game. So the data numbers are the players, and the obviously the numbers in the chart are how many the player did. So as you can see in the correlation, the blue, the R value is the relationship value, so how related the data is, and if it's 1, it means they are very very similar, and you could compare them. And then also the p value is how reliable the data is. So if it is under 0.05, then it is known as to be very reliable, and you can sort of trust the data. So yeah, in that I looked at my performer and saw the statistics that he was making. Yeah, and sort of took graphs like on here. So these are the graphs that I sort of compared my performer to. So 2 points scored, comparing that to the mean, and the best performer. So in the red is the missed and the blue is the scored. So unfortunately, my player didn't score any, and also missed 5. So that is quite a negative for that part. And then also compared passes and assists to see whether if you made more passes, you were more likely to get more assists, which was reasonably true for if you see the top and the middle. The top made less passes and got less assists. The middle made more passes and got more assists. So sort of had a correlation there. And then also distance covered on the court. For a small forward, it's quite important to see distance covered, as they should always be on the move looking for the ball around the court. So the covering the more distance is quite important for my players' positioning. For 6.2, this was about the technical model. So the technical model was how comparing my performer to the perfect model. So the on the left in the images is the perfect model, which is Blake Griffin, who is a professional NBA basketballer, and on the right are images of how my performer did it. And yeah, I compared the two, and then sort out problems with the performance. And yeah, so I just compared the two, and I noticed the differences. For 6.3, we went to Brighton Uni, and this was when we stood on force plates, and did a jump, and we got lots of data from this. So, for example, firstly, the net force created. So my performer, he is in the middle. Yeah, so the on the left is the sort of, I compared him with one person. So the one person's data is on the left. One person's data is on the left, sorry, and one person's in the middle, and the mean obviously on the right. So firstly, my players result in net force, was less than the person I compared him to. Um, but it is more than the mean, so that's quite a good thing. And then the duration of the phase was a little. It was nearer the mean than the person on the left, so you could say that's a good thing. But duration of the phase is how long the whole phase took. So yeah, so it depends how long they took to start the jump. As there was a process you had to do before it, so stepping on, and then also during the jump. So it may be different for different weights, different heights. So yeah. Then the net impulse created. Both of the players' net impulses were above the mean, and they're measured in Newton seconds. Um, yeah, both above the mean. My player not as much above the mean, but still above the mean. So this is quite a good score. And then we saw the mean velocity created, which is measured in meters per second. Um, and then yeah, so as you can see, my player was very high above the mean score for this, and also higher above my the player I'm comparing him to. Um, and the mean velocity is how quick the it took for the jump to occur. And then acceleration on the right, which is how the quickness of the start to the jump. As you can see, my player in the middle, still above the mean, but not quite as quick as the player on the left. So there is room for improvement for that. And then this is quite a important thing, I think, for especially a basketballer. So his time in air and jump height. Again, he's in the middle. So he is below the player I'm comparing him with both times for this. But he is near the mean. But the fact that he is below the other person could potentially mean he could get beaten to the basketball in the air, for example. If the ball was in the air and they had to jump up to get it, he would not be able to get as high in the air as another player, which is a negative. Sorry. And then, yeah, so comparing those two or using those two together give sort of quite a important part to basketball. Um, yeah, so for a tip off, for example, trying to beat an opposition in the air. So I've constructed targets I would like him to improve on for the next time for the future for his basketball. And that's for 6.1, 6.2, and 6.3. So 6.1 was his for it was the game situation where I constructed the schematic and got all the tally statistics. Um, so I noticed my player was not moving around the court as well as effectively for a small forward. So yeah, his movement was quite inconsistent. So he was unable to get on the ball a lot to do his job for the team, which was creating gaps in the opposition's back line. Which is to create gaps in the opposition back line. This can be done in a few ways. Well, sorry. I use the schematic to see the movement, so I'd like it to be less inconsistent in the future. Because as a small forward, it's sort of like a position you like to go up and down in that position, but for this, it just looks like he's going all over the place. Um, Obviously, doing a heat map may have been more, um, precise or yeah, but we didn't have that technology available to us at the time. So ways of improving his movement around the court would be to maybe watch a professional NBA small forward for a game or couple games.